Once dried, the aggregate travels upward through a bucket elevator that can move hundreds of tons every hour. At top, vibrating screens separate the material into different size categories. Fine particles fall into one compartment, medium particles into another, and imagine waking up tomorrow and discovering that every road on Earth had vanished overnight. No highways, no city streets, no rural lanes connecting towns. Food trucks couldn't reach supermarkets, ambulances couldn't reach hospitals, and entire economies would grind to a halt within hours. Yet most people drive across roads every day without ever asking a simple question. How are these massive ribbons of engineered stone and asphalt actually built? Think about this. A modern highway can carry tens of thousands of vehicles every single day while enduring scorching summer heat, freezing winter temperatures, torrential rain, and the crushing weight of fully loaded trucks. Some roads last for decades, supporting billions of tire rotations before major reconstruction becomes necessary. But here's what nobody tells you. Beneath the smooth surface you see lies a hidden structure as carefully engineered as a skyscraper. Road construction is one of humanity's largest manufacturing operations. Every year, billions of tons of stone, sand, gravel, bitumen, and concrete move through gigantic industrial systems to create the transportation networks that keep the modern world alive. And this journey begins far away from cities, deep inside enormous quarries and mines where the raw ingredients of every road are born. Section 1. Raw materials. Most people assume roads simply come from asphalt plants. In reality, the journey starts in giant rock quarries spread across countries like the United States, Canada, Australia, China, India, and Germany. Engineers search for extremely hard rock formations such as granite, basalt, limestone, and dolomite because weaker rock would quickly crumble under traffic. A single kilometer of four-lane highway can require more than 20,000 tons of aggregate material. The extraction process begins with drilling. Giant hydraulic rigs bore deep holes into solid rock, often reaching depths of 10 to 20 meters. Workers then load these holes with carefully calculated explosive charges. When the blast occurs, the ground shakes, dust erupts into the sky, and thousands of tons of rock break apart in seconds. What happens next surprised even experienced engineers when modern technology dramatically increased productivity. After blasting, gigantic excavators weighing more than 800 tons load crushed rock into haul trucks large enough to carry entire houses. These machines move continuously, often 24 hours a day. The sound of diesel engines echoes through the quarry while steel buckets tear into fractured stone. Every minute counts because a modern road project can consume astonishing amounts of material. The rock then travels to crushing plants where industrial crushers reduce boulders into precisely graded aggregate. Massive steel jaws squeeze stone with crushing forces reaching hundreds of tons. Conveyor belts stretch across the facility carrying endless streams of material while vibrating screens sort particles by size. The final product must meet strict engineering specifications because even tiny variations can weaken an entire road structure. But crushed stone is only part of the story. Roads also depend on bitumen, the black sticky substance that binds asphalt together. Bitumen originates from crude oil extracted in regions such as the Middle East, North America, South America, and parts of Asia. During oil refining, engineers separate fuels like gasoline and diesel, leaving behind heavy residual materials that eventually become road-grade bitumen. Most people never think about this, but the smooth road beneath your tires may contain material that traveled thousands of kilometers before reaching a construction site. Ships transport bitumen across oceans. Freight trains haul aggregate between regions. Trucks complete the final delivery. Some road ingredients travel farther than the people who eventually drive across them. The environmental impact is enormous. Quarry operations consume vast amounts of energy, while bitumen production depends on petroleum refining. To reduce this footprint, engineers increasingly recycle old pavement. In some regions, recycled asphalt now replaces a significant portion of newly mined material. Roads are no longer just built from the earth, they are increasingly rebuilt from their own history. And this is where the story becomes truly extraordinary. The raw materials have been mined, crushed, refined, sorted, and transported. But they are still only ingredients. The real transformation happens inside gigantic asphalt plants where stone, heat, chemistry, and precision combine to create one of the most important engineered products on Earth. Section 2. Manufacturing process. The moment the raw materials arrive at an asphalt plant, the real manufacturing process begins. At first glance, the facility looks like a maze of steel towers, conveyors, storage silos, and giant rotating drums. But every machine has a precise purpose. The goal is simple yet incredibly demanding. Transform cold stone and sticky bitumen into a perfectly engineered road surface capable of surviving decades of punishment. The process starts with aggregate feeding. Crushed stone of different sizes enters separate cold feed bins where computerized systems control the exact flow rate of each material. Conveyor belts move the stone toward a giant drying drum rotating at roughly 8 to 12 revolutions per minute. This drum acts like a massive industrial oven, preparing the aggregate for the next critical stage. Inside the drying drum, temperatures soar between 150 and 180 degrees Celsius. Powerful burners fueled by natural gas or fuel oil blast hot air through the rotating chamber. Moisture trapped inside the stone instantly evaporates into clouds of steam. The roar of the burner sounds like a jet engine, and the intense heat can be felt from dozens of meters away. Most people never realize that even a tiny amount of moisture can ruin an asphalt mixture. Water prevents bitumen from properly bonding to aggregate. That is why drying must occur with extreme precision. Sensors continuously measure temperature and material flow while automated controls make adjustments every few seconds. Larger stones into separate storage bins. Now comes the ingredient that gives asphalt its remarkable flexibility. Bitumen arrives heated and stored in insulated tanks at temperatures between 150 and 170 degrees Celsius. Pumps move the thick black liquid through heated pipes that prevent it from solidifying. Up close, the material resembles molten black glass slowly flowing through a network of steel arteries. Inside the mixing chamber, everything happens at exactly the right moment. Hot aggregate enters first. Bitumen follows. Giant paddles rotate at high speed, coating every particle with a thin film of binder until the entire batch becomes a uniform black mass. The finished asphalt leaves the mixer at temperatures near 160 degrees Celsius. Trucks line up beneath storage silos where thousands of kilograms of hot material pour into insulated beds. Drivers must move quickly because every degree lost during transport affects paving quality. Hours later, those trucks arrive at the construction site. Here, another fleet of machines takes over. The paver slowly advances, spreading asphalt in a continuous layer while operators constantly monitor material flow. But laying asphalt is only half the battle. What happens next determines whether the road lasts 5 years or 50. Massive steel rollers weighing up to 20 tons begin compacting the surface. Their drums press down with enormous force while vibrating systems generate thousands of impacts every minute. Engineers target specific density levels because density controls durability. Too many air voids allow water infiltration. Too few can cause cracking. Modern crews often complete multiple rolling passes while infrared sensors track pavement temperatures in real time. As the road cools, an extraordinary transformation takes place. The once soft mixture hardens into a durable surface capable of carrying thousands of vehicles every day. Drivers who later travel across it may never realize that an intricate manufacturing process involving heat, chemistry, timing, and precision made their journey possible. Section 3. Technology and quality control. Long before the first car drives across a new road, engineers begin a relentless inspection process. Modern highways are among the most heavily tested structures on Earth because a single hidden defect can eventually grow into a dangerous pothole or structural failure. One of the first tools engineers deploy is laser scanning technology. Vehicles equipped with high-speed laser sensors travel across the pavement while collecting millions of measurements every kilometer. These systems detect tiny surface deviations often smaller than a single millimeter. But smoothness is only part of the story. Engineers must also verify what lies beneath the surface. Ground-penetrating radar sends electromagnetic waves into the pavement structure and measures the reflections. The technology allows inspectors to identify hidden voids and thickness variations without cutting open the road. Inside quality control laboratories, another level of testing begins. Workers extract cylindrical core samples from completed pavement and transport them for analysis. Technicians measure density, air void content, binder distribution, and structural integrity. What happens next surprised even veteran construction professionals. Massive testing machines apply forces that simulate years of traffic in just a few days. Hydraulic actuators generate loads exceeding tens of thousands of kilograms while repeatedly stressing pavement samples. Temperature testing pushes roads even further. Specialized chambers expose samples to conditions ranging from -40 degrees Celsius to more than 70 degrees Celsius. Engineers want to know exactly when cracking begins and when softening occurs. Artificial intelligence now plays a growing role in road quality control. High-resolution cameras mounted on inspection vehicles capture thousands of images every second. AI systems instantly search for cracks, texture defects, and irregularities. Yet despite all this automation, human skill remains irreplaceable. Experienced inspectors often notice subtle warning signs that algorithms overlook. Decades of field experience sometimes outperform even the most advanced software. International standards demand astonishing levels of precision. Thickness tolerances may be limited to only a few millimeters. Density targets often exceed 92 to 96% compaction. In some large projects, rejection rates remain below 2% thanks to advanced monitoring systems. Every truckload, every batch, and every paving pass generates valuable data. Modern road construction has become as data-driven as aerospace manufacturing. Section 4. Global Facts. Imagine drawing a line around the Earth at the equator. Now imagine building enough roads to circle the planet more than 100 times. That's the scale of modern road construction. Every year, governments and private companies spend hundreds of billions of dollars building, repairing, and expanding road networks. Roads represent one of the largest ongoing engineering investments in human history. The world's largest road networks belong to countries such as the United States, China, India, Brazil, and Russia. Together, they account for a significant share of global transportation infrastructure. Here's a shocking fact. A modern 6-lane highway can require hundreds of thousands of tons of aggregate, asphalt, concrete, and steel. Some megaprojects consume more raw material than entire manufacturing industries in smaller countries. Did you know that road construction directly and indirectly supports millions of jobs worldwide? Quarry workers, refinery operators, truck drivers, surveyors, engineers, machine operators, laboratory technicians, and planners all contribute to the process. Did you know that some of the earliest engineered roads date back more than 2,000 years? Ancient civilizations built transportation routes using stone, gravel, and sophisticated drainage systems. Many of the engineering principles used today have roots deep in history. Did you know that recycled asphalt has become one of the most reused construction materials on Earth? In many regions, old roads are milled, processed, and incorporated into new pavement, reducing waste and lowering costs. Over the last 50 years, road construction has transformed dramatically. Surveyors once relied on manual measurements and paper maps. Today, satellites, drones, GPS systems, laser scanners, and artificial intelligence guide projects with extraordinary precision. And this is where the future becomes truly extraordinary. Engineers are developing self-healing asphalt, solar-integrated road surfaces, intelligent traffic monitoring systems, and sustainable low-carbon materials. The roads of tomorrow may be smarter than anyone imagined. Oyuto. From explosive quarry blasts and giant crushers to roaring asphalt plants and precision-controlled paving machines, every road tells an invisible story. It begins deep within the earth, passes through vast industrial systems, and emerges as the smooth surface that millions of people depend on every day. Think about this the next time you drive down a highway at full speed. Beneath you lies a carefully engineered structure built from millions of individual particles, shaped by heat, pressure, chemistry, machinery, and human expertise. What appears simple on the surface is actually one of the greatest manufacturing achievements in modern civilization. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.